Hello, everyone. Welcome to this month's Southern Plains Drought webinar. My name is Joel Lisenby. I coordinate the Southern Plains Drought Early Warning System at the National Integrated Drought Information System, or NIDIS. I also sit at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado in Boulder. If this is your first time at the Southern Plains webinar, welcome. We hope you get some useful information from the talks today. This is the third in a series of webinars hosted by the Southern Plains Drought Early Warning System for 2026. We host these every other month, and the next one is scheduled for August 18th. NIDIS is a multi-agency partnership that coordinates drought monitoring, forecasting, planning, and information at federal, tribal, state, and local levels across the country. If you would like to learn more about NIDIS or about the Southern Plains Drought Early Warning System, you can find out more about us at drought.gov. On this webinar, everyone is muted, and the webinar is being recorded. The recording will be made available on the NIDIS YouTube channel and linked from the webinars page at drought.gov/webinars. And we'll send an email with the webinar recording after it's been posted, and that might be in a day or two. We'll have some time after the presentations today for a few questions, and I'll read the questions to the presenters. If you'd like to ask a question, in WebEx, you need to use the Slido feature. And if you're joining from the WebEx app, Slido feature is fairly prominent. But those of you that have joined using the web browser, you first have to click this Show Apps button at the bottom right, and then select Slido to open the Q&A feature. So it looks like this. I'm really looking forward to the presentations today. We'll first hear from Mack Morris. Mack is a meteorologist at the National Weather Service office in New Braunfels, Texas, covering the south central parts of Texas. He has a bachelor's degree in meteorology from Valparaiso University and has been working for the National Weather Service since 2020. Before working for the Weather Service, he was a broadcast meteorologist and an aviation meteorologist in the private sector. Immediately following Mack's talk, we'll hear from Molly Wolzen. Molly is the Midwest Drought Early Warning System Coordinator at NIDIS, and also affiliated with the Cooperative Institute for Research in Environmental Sciences at the University of Colorado Boulder. Following both of those talks, that's when we'll have some time for discussion and Q&A. So have your questions ready as they go. So that's it for the introductions. I'm going to pass over to you, Mack. Take it away.
Sounds good. Thank you, sir. So I'm going to go over present and future drought conditions today. I'm Mack Morris. Once again, I work for the Austin-San Antonio National Weather Service office. We have had some pretty significant drought for the last 4 to 5 years, a good chunk of South Texas, and not just our area, but you know how drought kind of waxes and wanes. It's kind of been constant for us the last 4 to 5 years. So this spring so far has been quite helpful, and we'll get over that here in just a little bit. But our current drought conditions, going through some of the info here, as of last week, so the drought monitor gets released every Thursday, and those changes are made on Tuesdays. So we coordinate with folks from Oklahoma, Arkansas. Here in Texas, we have several meteorologists from each office, and then other folks within the agency, and also kind of coordinating about what changes to make each week. And then just basically over the last 4 weeks, there's been quite a bit of improvement over Texas and Oklahoma, as well as in central Kansas. However, there have been some degradations in the Texas Panhandle and western Oklahoma. There's now some exceptional drought in the Texas Panhandle and western Oklahoma. And recent extreme and exceptional drought has mostly impacted those areas. There has been some recent drought further south, but that's kind of been erased. So far this spring, you see lots of those improvements, especially over deep South Texas, where they've seen significant rainfall. Recent precipitation conditions, the past month has been lower than average for this time of year for southern Kansas and for portions of western Oklahoma and northern Texas. However, a good chunk of central, western, and then southern parts of Texas have seen above normal rainfall over the last month or so. So that has been quite helpful considering long-term drought impacts here. And we'll get over that here in just a little bit. And as far as temperatures go, it actually was a rather warm spring for western Oklahoma, western Kansas, and even the Texas Panhandle and Oklahoma Panhandle. But it was actually cooler than normal for a good chunk of central and southern Texas, where we've had a more cloudy and rainier spring, mostly since early April. March was actually quite warm. It was actually the warmest March on record for several climate sites in south central Texas, as well as in portions of deep south Texas. So there's been some welcome pattern change over the last couple of months here. But overall, May temperatures were near average for a good chunk of the region. And in terms of evaporative demand, obviously still significant and extreme to exceptional drought in western Oklahoma, the Texas Panhandle, and southern Kansas. Evaporative demand in the last 4 weeks has been a bit higher than average for this time of year for those regions, but there's actually been some rather wet conditions for southern Texas and even southwest Texas. In terms of stream flow, this is one of the things that's the biggest indicator of drought, at least in terms of long-term drought. Now, recently there were some changes at the USGS in terms of showing stream flow conditions. If we look at the 4-week stream flow conditions or the 28-day average, there certainly are some big-time positives over a good chunk of south and central Texas, but even in Oklahoma and even western Kansas, you notice that there has no longer those stream flow conditions at low. They're still much below and below normal conditions, so significant rainfall is still needed, but there have been quite a few improvements as of June 8th with continued hydrologic drought also across western Oklahoma. One thing to note is you see some locations kind of interspersed with some green, which means normal conditions and even above normal stream flow, and then even below normal and much below normal kind of juxtaposed with each other. And the reason for that is there's just kind of a slower response in some of those streams compared to other areas. And since this is just a 1-day average stream flow, you're not going to see those long-term averaged out conditions like we used to show on some of these maps. So take it with a grain of salt, seeing those much below conditions, at least for 1-day average stream flow conditions. The soil moisture conditions have been quite dry over Oklahoma and even southern Kansas. There's actually been some improvement on this map over the last week. Soil moisture, the first 1 meter or so of the soil moisture, so the first 100 centimeters, shows lingering dryness across Kansas, most of Oklahoma, especially western Oklahoma and northern Texas. But if you look further south and even out into southwest Texas, there's been quite a bit of rainfall the last couple of weeks and even the last couple months. So we're seeing higher soil moisture in those locations. So what does this mean for our forecast and outlook? So there's some things we've been talking about in recent weeks: El Nino, ENSO. We'll talk about that in a little bit as well. But the drought outlook is something we are interested in. So in the weeks ahead, we've had some pretty good rain. The last couple of weeks, we have some really good rainfall. And then the next 7 days, there is forecast to be significant rainfall for central and eastern Oklahoma. We would like to see a little bit more of that towards the Texas Panhandle and areas that are more impacted by the severe and even up to extreme and exceptional drought. But I think most of these areas that are within the heavier rainfall for the next 7 days will provide incremental drought improvement for those regions. In terms of the temperature outlook, actually does call for above normal precipitation and even near normal to below normal temperatures for Kansas and Oklahoma, but odds slightly favor a warm and wet second half of June for the southern plains. Now for the summer, this outlook was released a couple of weeks ago, but June through August is likely to be warm. But in comparison to the last couple of years, these graphics look really tame. The last couple of summers have been downright miserable at times for good portions of the southern plains in terms of the extent of the heat and the duration of heat and lack of meaningful rainfall in the summertime. But there are equal chances for above or below normal precipitation for the next couple of months as well. So that's a good sign. And like I mentioned, the drought outlook, June through August, does call for improvement For a good chunk of the Southern Plains, the only areas that might see drought persist would probably be over central and maybe east central Oklahoma. But we might even see some drought removal. That doesn't mean the drought's going to be disappearing completely. It still will persist through the summertime months. Now, we had mentioned ENSO, which is the El Nino Southern Oscillation. It has two phases, actually three phases. There's neutral, there's La Nina, and there's El Nino. Neutral phase, we're still borderline neutral phase, but we're getting closer and closer to El Nino conditions as of a couple of weeks ago. I believe their new outlook is coming out sometime in the next week for the Eastern Pacific. This is the outlook I'm talking about here, those outlook probabilities, the strength probabilities for El Nino. Now, something to keep in mind is one thing to keep in mind is a strong El Nino doesn't necessarily mean strong impacts. Now, we have a higher chance for stronger impacts with a stronger El Nino. That doesn't guarantee significant impacts, though. So typically during an El Nino year, these are based on reanalysis from NCAR and NCEP from 2015, 97, 87, 82, all the way back to 57, and a couple of other years mixed in there. The precipitation rate anomaly is typically centered over Texas. We'll see higher precipitation during El Nino winters and springs. This usually doesn't impact the region during the summertime. What we're showing here on the left is May through September. So there might be a small correlation there, but the correlation is typically a lot higher over the southeastern United States and even the West Coast. But the Southern Plains, particularly South and Central Texas, do typically see higher precipitation during the winter and early spring months during El Nino. And that's all I have. Thank you so much. Do you need to start presenting, Molly? Do you need me to stop presenting for you?
I'll just jump in. Thank you very much, Mac. That was great. Sorry, it took me a minute to unmute. Yeah, Molly, go ahead and share your screen and take it away as soon as you're ready.
All right. I'm assuming you guys can see that okay?
Looks great.
Okay, wonderful. Hello, everyone. My name's Molly Wolozin, and I am, as Joel said, one of the regional coordinators with NIDIS, and I'll be talking with you today about drought indicators in the Southern Plains. So the project I'm talking with you about today started with the motivation about understanding a little bit more about the different relevance of drought indicators across different times of the year and across different locations. Monitoring drought is fairly complex, and it does involve tracking multiple indicators like we just saw in the previous presentation, including precipitation, evapotranspiration, soil moisture, and other variables. And the motivation for this project was really to improve our understanding of what drought indicators we should be looking at different times of the year, and during different locations as well. And having an accurate drought assessment can help us with more effective drought planning, decision making, and communications. So the project that we started with to answer this question was partnering with NASA. And for this study, the NASA scientists conducted research to quantify the relative importance or drought explainability of specific indicators with respect to the U.S. Drought Monitor. So this study looked at a range of 113 different indicators of drought, and they used a strategy called mutual information to analyze the information. And if you're interested in looking at the results of this study, they are published in the Journal of Hydrometeorology, and you can follow that QR link, and I can also put the link in the chat box here soon. The regions that this study looked at are shown on the screen. And so the Southern Plains is kind of covered by two different regions. So Texas and Oklahoma were included in the South region, and then Kansas was included in the High Plains region. And I'll talk a little bit more about the regional results here in just a second. I did just want to give a quick snapshot to show you what indicators were included in the study. Obviously not going to mention all of these, but it ranges from a variety, including precipitation variables, soil moisture, evapotranspiration, stream flow, and other indices as well. So there are a few research caveats that I wanted to mention. The first is that this study does use the U.S. Drought Monitor as the training target from the time period of 2006 to 2019. So if the study were to use a different training target or time range, that could produce different results. This study, even though it does look at the U.S. Drought Monitor, it cannot tell us what data sets were actually used by the authors, but it can tell us what data sets have correlation to the U.S. Drought Monitor. In terms of the indicators and timescales that were included in this study, some indicators that are used by state and local governments were not included, like reservoir levels. Also, compared to other data sets like precipitation, there was a fairly limited number of data sets like runoff, stream flow, and snow water equivalent. And also, the time scales used in the study ranged from 1 month to 72 months. And so for flash drought, shorter time scales could be relevant, and we're not going to see those show up in this study. So finally, the last caveat here is that the analysis was conducted at a fairly large regional scale, as I showed you on that previous slide. And geographies and climates are going to vary across these large regions. So there might be some different local relevance of other indicators. And also the study did look at just a 15-year period. And so you might see indicators that are important in other droughts just outside of that time period. And also the current drought could differ from what type of drought you had in that time period. So some of the overarching key takeaways from this research, the results overall show us which drought indicators are most representative of the U.S. Drought Monitor's depiction of drought for a given region and season. We also found that you have a higher drought explainability when you combine multiple indicators. So not just looking at 1 or 2 indicators on their own is going to give you the full picture. This study found that the top 15 indicators that ranked highest capture about 55 to 75% of the explainability for the U.S. Drought Monitor. So that means that we can use a select number of indicators to explain most of the drought conditions that we are seeing. Also, when you're looking at both model-based indicators and remotely sensed indicators, both of those individually showed promise for representing drought. And so therefore, using only model-based indicators shows promise for drought prediction and forecasting. And also for those that are remotely sensed, it shows value for drought monitoring where the data is fairly scarce. So I'm going to quickly highlight the results from the Southern Plains region, which again includes Texas and Oklahoma, as well as some other states. And so this study looked at the top indicators across all seasons and then individually by season as well. So I'm going to start here with the all season data. And the indicators that emerged as the top indicators, all levels of soil moisture, so 1 meter, 1.6, and also total column, as well as the Palmer indices, both the modified and the hydrological. And then for precipitation, the time scales that were most relevant were the shorter time scales of 3 months and 6 months. And then also runoff emerged as a top indicator for these states in the South. When we look at the seasonal data, here are just some kind of overarching takeaways. Soil moisture did emerge as a top indicator across all seasons in these states, as well as runoff. Stream flow is a top indicator for drought in the winter and spring in the South. When you are looking at precipitation indices and also SPEI, which is the Standardized Precipitation Evapotranspiration Index, you see some variation in the time scales by season. So typically when we're in the summer and fall, you want to look at the shorter time scales, the 3 to 6 month, and then for spring and winter, the longer time scales, anywhere from 6 to 12 months as well. So before jumping into the individual season data for the South, I did want to quickly look at the High Plains since Kansas is represented in the High Plains. But I did want to mention, I will show you an online resource where you can look at both of these regions in more detail towards the end of the presentation. For the High Plains, we actually see fairly similar top indicators for the High Plains for across all seasons: soil moisture, Palmer indices, precipitation. But what we see as a difference between the High Plains and the southern part of the U.S. is that the High Plains, typically for timescales, you should be looking at the longer timescales from 9-month to 12-month for both precipitation and also evaporation-based indicators like SPEI. If you look at the seasonal data for the High Plains, groundwater is actually a data set that emerges as a top indicator in the High Plains across all seasons except for summer. And you also have that same difference in timescales across seasons. So typically, longer timescales are more representative in the winter in the High Plains, and then shorter timescales in other seasons on the order of 6 to 12 months. Okay, so now I'm going back to the South, which again covers Texas and Oklahoma, and I'm not going to spend too much time on each of these slides, but just wanted to show some of the differences between the seasons. So summer, which is considered June through August, these are the top indicators. Again, you see the shorter time scales, so 3 months and for precipitation as well as SPEI, and also soil moisture and Palmer indices and runoff as well. When you get into the fall season, this is very similar to what we saw previously. You are getting into slightly longer time scales, like 6 months for both for precipitation. For the winter, this is where you see stream flow enter as well, which makes sense because a lot of times when we have winter drought, these are droughts that have persisted for a while. So it does make sense that you would want to look at the longer time scales and other hydrological variables like stream flow as well. And then springtime, again, we're looking at stream flow and runoff as well as the time scales on the order of 6 months to 12 months. Those longer time scales, likely conditions had persisted over winter, and that's why we see those longer time scales emerge. Okay, so as I mentioned, the results that I just presented were published in a journal article. And so I wanted to talk through the effort that NIDIS and NASA and our partners took to translate the results from this publication into an online resource. So this is a look at what the original results looked like in the publication. Obviously, it's not super user-friendly, and so NIDIS took the results and we translated them into an online version using the graphics that you saw in the presentation and also a different way to explore the data. And I'm going to just quickly open up this web page. And so if someone wouldn't mind just putting a link to this page in the chat, or I can do that after the presentation. But this is available on drought.gov, and you can look at information about the research that I just presented. We have the overview as well as the caveats that I talked through, but you can also look at the overarching research findings and then look at it by region. So once you get down to exploring the regional takeaways, you can jump to any region. I'm going to go to the High Plains, and it shows you can expand any of these gray bars to look at the all-season data. If you scroll down, it talks about some of the seasonal takeaways, and again, you can expand and collapse any of these seasonal data information. One thing that we wanted to provide on this resource was a way to look at the data in more depth. And so at every top of the seasonal data, I'm sorry, for each region, you see a button here called Explore the Data. If you jump to that page, you're actually able to interact with a table that provides you more information. So I'm going to switch it to the south here, and I want to look at the data for the summer. And so this provides you the grouping of the different indicators that came up on top, and it provides a quick definition And it also provides links to the data sets that were used in this study, but we also wanted to link to additional data sets. So if you wanted to learn how you can monitor soil moisture, what tools are available, you can use this additional data sets column to access that information. So again, I encourage you to explore the region that you are interested in, either the South or the High Plains, and definitely, let us know if you have any questions as you are exploring the data. Let me just I think I just am on the last slide here. So right now, NIDIS is in the process of continuing to explore ways to produce the same sort of information at a finer scale. So at the state scale or the watershed scale. We are moving forward in our different drought early warning systems with some conversations about this. And I know Southern Plains, this will be a topic that is discussed at future meetings. And we would definitely welcome any feedback on approaches or what would be most useful to you or what you would like to see as well. And if you're interested in signing up for any of the newsletters from NIDIS, you can follow that QR code to sign up for a newsletter. So that is all I have, Joel.
Great. Thanks, Molly. So much information and very interesting. Thanks for going through that NASA Indicators project and even showing on the website where to find some of the, not only the results of that study, but also the data. We have a little bit of time for some questions. If anybody would like to ask questions, go ahead and put them into the Slido application within WebEx. And while you're doing that, I'm going to get things started with a couple of questions for each of the presenters. First, for Mack. Mack, I think you did a fantastic job explaining how we're starting to see some improvement to drought across the region. In fact, on the fairly large scale, we're seeing a pivot now from years of very dry conditions across Texas and up into the high plains of Oklahoma and Kansas, but we're transitioning now into a more wetter pattern. Can you tell us a little bit more about what things look like on the ground for you in New Braunfels or just South Central Texas in general? Are you starting to see a change in the landscape as we see those drought conditions ameliorate?
Yeah, Joel, I definitely will say that my backyard is very green. The side yard, is quite wet. So yeah, in terms of rainfall recently, the yard every week. So we've been getting good amount of rainfall, and then we dry out a little bit, and then we get more rain. So there's been time for the water to kind of soak into the soil, which is, I think, a big takeaway here is we haven't had a lot of like heavier, like big time severe thunderstorms in the area this spring, which is what we typically get, where we get more severe weather reports. This spring we've had several cold fronts in April and even into May, which is extremely unusual. Since I've worked here in 2020, I don't think I had seen a cold front in late April or even mid-April before this year. So certainly a pattern change that's been quite welcome. Obviously, we still have a long ways to go, but in terms of short-term drought relief, this will definitely help us get through the summer. And one other thing to note is the significant population rise in the Southern Plains, particularly in Texas, along the I-35 corridor from Dallas south all the way into San Antonio, certainly has raised those water concerns, and that even stretches further towards the coast, towards Corpus Christi, into the Houston area. So obviously with this drought the last 4 to 5 years and the tremendous population growth, that kind of being in conjunction hasn't really helped things too much. But we are starting to finally see some response in the aquifer levels, and as well as some of the wells in Bexar County, which is where San Antonio is located. We still do have some reservoirs that are quite low. A couple of them, to name just a few, one of them would be Medina Lake, which is in Medina County, just west of San Antonio. They doubled their capacity to 4%. So that's telling you how dry it has been the last several years. And even after the flooding last summer in the hill country, Canyon Lake, which is where good chunk of that water went Canyon Lake and then Lake Travis, which is up in west of Austin. Canyon Lake's just west of New Braunfels. But all the rainfall from the hill country went into both of those reservoirs. And even after that, Canyon Lake is still only about 60% full. So that tells you how much water we still need in the area. I think that kind of answers your question. But
Oh, it absolutely does.
Yeah.
No, that's fascinating. And I've heard people use the term a green drought in situations like this before, where you've had enough rain for things to green up, but the reservoirs are still low, and it will take some time and more than just one good season to make up for 5 or 6 years worth of drought. So thanks for explaining all of that. That was great. Molly, my next question is for you. You showed a list of the top drought indicators that people could use. Soil moisture rose to the top in, I think, every season, or at least most seasons. But there were other indicators below that. But I guess my question for you is about the ranking. How much weight should people be putting on the ranking of these different indicators when they're applying this research or deciding which indicators to use in their own drought analysis?
Yeah, that's a good question. Overall, when we are looking at, I'm just gonna, since I have my slides up, I can go back a few slides here. So for instance, if we're looking at these top indicators, this actually does represent the top 15 indicators, and that is for the spring, looking at different time scales too. And really, how this study was done, it doesn't necessarily rank any of these over others. So this was the top 15 out of 113. So this in general, there's not necessarily a ranking, but just trying to give you an idea of the different types of variables that you should be looking at. So it's not necessarily saying that soil moisture is better to look at than 6-month precipitation. It's just saying you can get a better picture of drought by looking at both of those together, if that answers your question.
Sure does. Fascinating. Thanks for that. So I think, if I were to say back, what I'm understanding is that all of these would represent tools in your drought toolbox, and the different tools would be useful for different applications, and not one of them is any better than the others, but these are the ones that as a group or as your whole toolbox, these are the ones that you should have to look at.
Yes.
Yep,
that's correct. Based on this study, again, there were those caveats of, if you were to look at different years, there could be different variables, but this is, I think, a good starting point for, those that are in the Southern Plains.
Great. Thank you. Mack, I'm going to go back to you for one more question. You shared the seasonal outlook for precipitation and temperature. You also talked about the long-range outlook with El Nino. Can you talk a little bit about the seasonal outlook for hurricanes and tropical storms that the National Hurricane Center released, I think it was 2 weeks ago?
Sure.
And not just what the outlook says, but what are you looking at in Texas specifically about this outlook?
So it's a little bit of two different kind of things, because we have the Eastern Pacific and obviously the Atlantic. So one thing that's been noted is that we're still kind of an ENSO neutral, kind of moving into El Nino conditions. Now, we don't usually see significant teleconnections between the two in the Atlantic earlier in the season, but towards the end of the season, towards like October and November, maybe even the September, we start to see more of that connection where there's more shear over the Atlantic, more suppression of convection. So that usually does lead to a quieter Atlantic season. However, early in the season, Gulf storms are more common, weaker storms typically, so that doesn't rule something like that out happening. And obviously, one of the things we always like to mention is it only takes one storm to make a season. And we've seen that time and time again in the last couple of years in the United States, where just one storm can basically write the history books for a hurricane season. Now, one other thing to mention here is the Eastern Pacific will probably be more active. Reason being is that warmer equatorial Pacific waters help fuel more convection with those westerlies and a more active conveyor belt. So storms will be more common, maybe more intense. And one thing that we notice usually in South Central Texas and even Southern Texas, you could even make a broader statement of saying in Texas during the fall months, that during El Nino seasons, whenever there's hurricanes in the Eastern Pacific, we typically see increased rainfall in the fall months if there is a tropical system, mostly because they'll get tied into at least that mid-level moisture will get any remnants that move inland over Mexico and make their way up into Texas or even New Mexico. Those remnants can team up with southward moving cold fronts in the mid to late fall months that could produce significant rainfall. And sometimes we've seen that typically in late October or even into the month of November, where we've seen systems like that lead to significant flooding for parts of Texas. So that's something to keep in mind as well. It's not just the Atlantic, but also the Eastern Pacific can play a role in our sensible weather.
Great, thanks. I like how you explained that it really just takes that one storm to put a season into the history books, and that fewer doesn't mean none, and that sometimes even later in the season, you can get surprised by a really heavy rainfall producing storm that moves north. So thanks for explaining all of that. This has been fantastic. I've really enjoyed both of your presentations. I don't have any more questions from the audience to go through, so we might wrap up just a little bit early. But I wanted to just thank you both again for sharing your time and your expertise with this group. And a reminder to those that are watching that this is being recorded, and I'll post the recording online here in the next few days. I'd like to thank all of you in the audience for coming and making time to learn more about drought and how things are changing in the Southern Plains. And we hope that you'll be able to join us again at our next webinar, which is currently scheduled for August 18th. And that concludes today's webinar. Thank you all.
Thank you.